Hey everyone, in this video we'll be understanding how to work with GitHub. So far we have installed Git, which is a version control software on our local machine, and used it to track changes in our code. While that works when it comes to tracking versions on our local machine, there are still some weaknesses in that approach. If something happens to our machine, whether it catches fire or our hard drive crashes, then all our changes are permanently lost. Doesn't matter how extensively we track them. Another weakness is we keep referring to this idea that Git allows us to collaborate with multiple people across our team. But in this case, it's very difficult to collaborate with another team member. For example, if I need someone else to look at this code and maybe make some changes in it, then I have to share this over a shared drive or Google Drive or something like that, and then they will download it on their own machine, make changes and upload it to the same drive. I'll get it back from there, but it starts to get very tedious and old school. This is where GitHub comes into picture. So in one of our prior videos, we already looked at this visual Git workflow. So far, what we have operated with is second, third, and fourth layers. So we have our code repository in our local machine, which we call workspace. And the moment we make any change and add it to our staging layer using git add command, it gets added to index. When we finally run git commit command, it makes it to local repository. And the part where GitHub comes into picture is this layer, upstream repository. And you can already see the message displayed at the bottom here. That upstream repository is basically a repository of your code to share and collaborate with other developers. It's hosted on cloud, and GitHub is not the only centralized upstream repository on cloud. There are other repositories like GitLab, Bitbucket, and the company which I work at, everything is on Azure. So we have something called Azure DevOps, which also has its own central repository like GitHub. But the idea behind learning GitHub is that if you know how to work with GitHub, it's very easy to adapt to any other cloud repository. So let's start working on this part where we'll be pushing whatever we have in our local repository to cloud upstream repository. And we'll first get started by signing up a GitHub account. So if you don't have a GitHub account, you can simply go to this site github.com, and obviously if you have it, you can simply sign in, and if you don't, then you can use sign up option here. In my case, I'll just continue with my Google account, but if you want to register some other email address, then you can use this options. So I'll continue with my Google account, and this is my Gmail account that I want to register with GitHub. I can continue from here. Okay, so we can create the account now. Okay, so now that we have our GitHub account created, let's start by creating a new repository by clicking on this profile icon on the upper right hand corner, going to repositories, and obviously we don't have any public repositories yet. So what we want to do is the repository which we have on our local machine, we want to push that repository to GitHub, and we'll start by first creating a repository here that we can push our local repository to. You can give any name to your GitHub repository. It doesn't exactly have to match with what you have on your local machine, but it's considered good practice to have both of them be the same. So we'll keep git practice. Always a good idea to add description, especially if it's a project that is serious and you want other people to also work on it. For now, we'll skip this part. We will keep the visibility of our project to be public. We can also keep it private, in which case it is only accessible to people that we give access to. We would not be adding a README file. Usually every serious project has a detailed README file that describes the project and how to work with it. For example, just to quickly show what a README file looks like on GitHub, we'll just search for PyTorch, which is an open source deep learning library. And if you go to GitHub repository for it, it will have a detailed README like so. It just tells you what the project is about and how to get it on your machine and work with it. For now, we will just not add any README. We'll discuss about Gitignore towards the end of this video, but for now, we'll just keep these options as default and move on to creating the repository. So now that we have created this remote repository on GitHub, it's already offering us suggestions on how to push local repository to this GitHub repository. For example, if we were creating new repository on our local machine, then this is the approach that Git is asking us to take. We create a README file using this command. We initialize a Git repository, we add that README file to our staging area, and then we complete the commit. But obviously we have done all of that. We already have a local repository which we have been working on, so we don't need to do any of this. We can simply use the second approach, which is meant for any existing repository that we need to push. So let us first try to understand what this command is. So if we go to our local repository, okay, what Git is asking us is to run this command, git remote add origin and this particular URL. Now before we run this, okay, let's clear this and run this command, git remote -add -v. And what this command does is it gives us the remote equivalent of this local repository. So if there is a remote repository on GitHub or any other central cloud repository where we are connected with, then this command will give us what are those URLs. In this case, because we have yet not connected this local repository to any remote cloud repository, it's not giving us anything. So what this command will do is it will tell Git to add this particular URL, which is a URL for our remote repository, with this particular alias or name, and this name is fungible. You can either have it as origin like Git is asking us to, or you can have it as any other random name. Doesn't matter, it's just an alias for this URL which is pointed to our remote cloud repository on GitHub, but by convention it's always origin. So let us copy this command and let us paste here. So git remote add this particular URL, which will be the remote URL corresponding to our local Git repository. Okay, so the moment we run this command and then we run git remote v again, now unlike the previous response, it is giving us remote URL equivalent for our local repository, and we will see what the difference between fetch and push is later in this video. Now let us run git branch all. As you can see, we have our master branch which we are currently on, and we also have this feature branch. Let's go back to GitHub and see what the next step is. So in this command, GitHub is asking us to change or modify the name of our branch to main. Somewhere around 2020, GitHub decided to have main as its default branch instead of master. So when we initialize our Git repository locally, by default a master branch was created, and then we ended up working with that as a reference branch, creating feature branches off of it. GitHub also used to have the same default branch until 2020 when it decided to have main as its default branch, right? So we will change the name of our branch to main. So make sure that you are on your master branch, because that's the branch which we actually want to push to our GitHub repository. And then once you're on it, you can run that same command, git branch -m main, and this will modify this master to main. And as you can see, it's already modified, and we can run our git branch command again to confirm that part. So now once that is done, the last step will be to run this command. What this command means is it is telling Git to push our main branch, not explicitly, but it will be the main branch because that is the branch which we are currently on. But essentially it's telling Git to push the branch which we are currently on to origin, which is the name of our remote URL. It's an alias for our remote URL, and to do so while creating a main branch in the remote URL, because our remote GitHub repository currently doesn't have any branches. It's still an empty repository. If we have a different branch here, right, say if we decide to have a random branch, then it will push the contents of our current branch to the remote URL, but it will be pushed to this particular branch and it will be created anew. But obviously that makes no sense, so we'll just keep it as main. Another thing to notice here is this use of -u. So this is a shorthand for -set upstream. So we also could have, instead of git push u origin, use this set upstream origin main, and both of this mean the same thing, and that is not only should git push our current branch to the remote branch, but it should also set that remote branch, or rather that remote URL, as its upstream default. So next time when we push our changes to remote repository, we won't need to give this part. We will simply run git push and it will do the rest. But when we are doing it for the first time, we have to run this command to make sure that this particular remote repository is set as the upstream for our local repository. Okay. So before we run our git push command, I almost forgot to mention this part. When we run git status command, it's giving us the expected out. We are on branch main. There is nothing to commit and our working tree is clean. But this will change the moment we run git push successfully. And I just wanted to bring that to your notice before pushing our local repository. Okay, so now let us run command which GitHub asks us to run, git push u origin main. Okay, and the moment we run this, if you're doing this for the first time where you haven't yet pushed any local repository to your GitHub account, it will ask for a way for us to set up some credentials. Now there are different ways you can set up credentials between your local machine and GitHub account. For now we will opt for the simplest one, which is using this sign in with your browser option that GitHub is providing us. So when we click on that, it will go to your default browser, and because we have logged into our GitHub account already, it's prodding us to select that GitHub account as our remote repository. So this is our GitHub account. So the moment we authorize Git, it will ask us to verify via email, and then obviously I'll have to go to my email and submit the authentication code. So once we are done submitting that verification code, we have established authentication between our local machine and GitHub account. And if we go back to our VS Code, we have successfully pushed our local repository to that GitHub repository, right? So this is the point where it was waiting for us to finish our authentication, and then it ended up pushing the contents of our local repository from main branch to main branch, okay? And this is the URL that those contents are pushed to. It is also important to notice that local branch main is set up to track our origin main branch. branch. If we run git status now, this part is expected on branch main, and this is also expected, but there is one more addition to our output, is that git is telling us that your branch is up to date with origin main, meaning our local branch main is up to date with our remote branch that is located at origin. Origin is our remote repository and main is our remote branch. We can go to GitHub and we can click on this repository, and at this point it's not empty anymore. Whatever we were working with on our local repository is also now there in our remote GitHub repository. And as we can see, there is this main branch, which is what we pushed our changes to. So if we now want to make some change in our local repository, let us also add one more cloud skill. Say we want to learn AWS now. So learn Amazon Web Services, associated tools. Okay, we run git status. Your branch is main, your branch is up to date with your remote branch, and we have this untracked file. So adding this file to our staging layer, running git status, it's telling us that these changes have to be committed, and we will commit. Added plan to learn AWS. Let us run git status again, and notice what it's giving us in the output now. We are on branch main. Your branch, meaning your local branch, is ahead of origin main by one commit, which makes sense, right? Because we made one commit, which we have yet not pushed to remote repository. This will be even more evident when we run our git log command with the branching view. At this point, our local branch and our remote branch were in sync, and then we added plan tool on AWS. Our head commit, which is pointed at our local main branch, is one commit ahead of where our origin main branch is. And this time we won't need to run the entire git push u origin main command. All we need to do is run git push, and it will by default push to the main branch in our remote repository without asking any credentials from us, because we have set all of that up already. So as we can see, it has pushed the changes from our main local main branch to our remote main branch. Okay, and let us confirm that part by refreshing this. So this is the latest commit which we added. This was our commit message, and we basically added this aws.txt file with this content. Okay, going back to our repository. So at this point we are safe from anything happening to our local machine, because we have already pushed our code to cloud and it is safe there, and we can always get it from there. So let us mock a scenario where we might have to collaborate with some other team member over the same repository. Okay, so let us go back to VS Code and let us cd out of this folder, create a new folder, collab simulation. Okay, and we can see our collab simulation folder has been created, so we will cd into that. Let us now try to bring our remote repository into this folder. And at this point, we are assuming that some new team member is wanting to make changes to this repository. So the first thing that person has to do is get this repository to their local machine. We will be doing that by running this command, git clone the URL of that remote repository. So you can go to this option code, and it will suggest this HTTPS URL, okay, which is a URL for our remote repository. Copy that, run that after our git clone command. It will bring that remote repository to our local machine. So we don't have to share our code with each other over shared drive or something as primitive as that, right? We can simply clone that repository into our machine. And what that will do is bring that repository here. It's not just the repository, but it will bring the entire history. I made a mistake. It has brought the history of our main branch. Obviously it did not bring our feature branch because we did not push that to our remote repository, right? It doesn't exist in our remote repository, but it brought the entire git history for our main branch the moment we ran git clone command. Okay, and at this point, say that new team member wants to contribute. What we want to do is want to open that newly cloned repository in our VS Code. Control KO. We will go to collab simulation, git practice, and this is the newly cloned repository. We will open our terminal and we'll go to git bash. Okay, and now we will be adding GCP plan to learn, and running git status will now tell us that there is something to be added to our staging layer. Then we'll just finish that commit. Okay, and then running git status, it will tell us that our local branch is ahead of our remote branch by one commit. Can run git push to push that to our remote repository, and that has been successfully completed. Now going back to our remote repository, refreshing this, we will have that commit which we just made. Added plan to run GCP, going to cloud skills, and we have that gcp.txt. And this is how collaboration works in a nutshell, right? You have this centralized repository here. It could either be a project in your company, or it could be an open source project, or it could be a personal project of yours. You want to now collaborate with some other team member. For them to contribute to this project, they have to first clone this on their local machine and then basically just start pushing changes to remote repository. So now let us go back to our old Git repository, the one which we have been working on. So Control KO, we'll get out of collab simulation and we will go to git practice, right? So as you can see, we don't have gcp.txt because that has been pushed by a different team member to remote repository. So running git status for sanity. Now let us add one more change to our repository. Okay, so add a new folder, and that will be for front end. Say we want to learn Gradio, right? We want to run Gradio. For people who don't know, Gradio is basically a lightweight out of the box front end. So what Gradio allows us to do is just create UI easily without having to worry about coding in JavaScript, because a lot of data scientists and machine learning engineers basically work with Python and are not well versed with React or any other JavaScript framework. Plan to learn Gradio for creating out of the box front ends for machine learning models. Okay, running git status. We have to add this change to our staging, and then we have to commit it, and let us clear this. Okay, running git status. At this point, we know that our branch is ahead of origin main by one commit, but what our local repository is not aware of is that there is another change in the remote repository. So it's not just that we have added a change locally, but our team member has also contributed a change and pushed it to our remote repository. So what happens when you try to push this to GitHub now? Yeah, it will reject it, right? Now the output is very descriptive. What Git is telling us that it's rejecting our push because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref, meaning someone has already pushed a change to the remote repository and your local repository is out of sync with the remote. If you want to integrate the remote changes, use git pull before pushing again. And this is where we can use git pull, at which point it will bring those changes from our GitHub repository to local repository. But there is another command that we can also use here. So remember when we run git remote -v, it's giving us two options. So there is something called fetch and there's something called push. The difference between when we run git fetch versus when we run git pull is git pull will bring those changes and will also merge those changes in our local branch. Whereas what git fetch will do is it will only sync our local branch to our remote branch without merging the changes from our remote branch. So git fetch will make sure that our local repository is aware of what has changed in remote branch. So for example, when we run git status now, it's not aware of any changes in the remote repository. It's just telling us that your local repository is ahead of remote by one commit, right? Which is not correct. So when we run git fetch, it's still not merged. My cloud skills still does not have gcp.txt. If I run git status now, it's giving me a much more accurate status that my local branch and the remote branch have diverged. You have one different commits each because I committed gradio.txt and my team member committed gcp.txt. Use git pull if you want to integrate the remote branch. Clear this. And we will run git pull. At this point, it will bring those changes. And because again, remember, we discussed this in our previous video that whenever two branches diverge, Git will not be able to merge them automatically. It will want us to write a custom commit message. And once we write that commit message, we save it, we close this file merge message. At this point, it will complete the merge by ORT strategy. And if you're not aware of what ORT strategy is, you can look at my previous video where I was discussing about Git merging. Okay, so at this point it has brought cloud skills gcp.txt. You can see it here. It has integrated the change that we had in our remote repository with our local branch. If we run git status, our local branch is ahead of our main branch by 2 commits, and we can even visualize that better in git lens. We added plan to learn Gradio, and then we brought this change, added plan to learn GCP from remote repository. When we ran git pull, Git asked us to write a custom commit message, and then it finished the merge. Going back to our terminal, and at this point we'll be able to successfully run git push command, and it will push both of these new commits to remote repository. And we can go to git practice. The head commit we have in our remote branch is custom commit message that Git asks us to write before finishing the merge. And this is generally how collaboration works. You will have a single centralized repository on cloud, which every team member will clone to their local machine. And depending on how many changes they have, they will keep pushing those changes from local repository to remote repository. Now, before I end this video, I just want to quickly explain what Gitignore is used for. Remember when we were trying to create our remote repository, GitHub gave us the option of creating a gitignore file. Usually what happens, so say if I have a file here, and in a lot of AI and ML projects, as well as any other Python project, there is a file called .env. And this file houses a lot of our credentials. For example, if we might have some username, random user, we might also have some password, random password, and we might have some API keys. For example, if you're working with ChatGPT or some other AI models, you will have your API keys stored, right? This will just be some random combination. A lot of these credentials you obviously need when you're trying to work on your code, but you also don't want to push this to GitHub. You don't want the rest of the world to see your credentials. So how do we get around this problem? Because the moment we added this file, and now if we run git status, Git has immediately started tracking it. Okay? It's asking us to stage this change and to commit it, and obviously after that we'll end up pushing this to GitHub. So this is where Gitignore file comes into picture. Gitignore is basically the file that is directly located under your project root. It's named as .gitignore. Okay, as the name tells us, anything that is there in your .gitignore file will not be tracked by Git. So in this case, for example, if we add .env in our gitignore file and then we run git status again, at this point it has stopped tracking .env. We add gitignore and we commit gitignore, even though we have .env on our local machine and we'll be using it when we are working locally, it will never be tracked and committed by Git. If we run our git push command, go to our remote repository. So this commit has made it to our remote branch and our gitignore file has made it, but our .env file has not made it. So that is the gist of what gitignore does. So any file or any folder that we don't need Git to track should be added to gitignore file. And usually every project, whether it's Python, JavaScript, React, etc., has its own standard gitignore file, and then we keep on modifying it depending on our needs. In fact, let us look at what a standard gitignore file looks like. We can do that by just creating a new dummy repository. We can go to repositories, we can create new repository, and we'll just name it some random repo, right? Anyway, we don't need it, we might end up deleting this. Instead of now keeping this default, we will say we want a gitignore file. GitHub is giving us different options. So Android, Angular, these are all different kinds of projects and different kinds of programming languages with their own respective gitignore files. Let us go to Python here. So select Python. Even let us add readme. Right? It will also add a readme file. It will just be basically this project name, and we'll end up creating this repository. So it has added a dummy readme file, and it has also added a gitignore, but this gitignore is specific for Python project, and it will be pretty extensive because when you work on production grade Python projects, it will end up having a lot of files and folders that are necessary for you to run your Python code locally, but not necessary to commit. In fact, in some cases, you definitely should not commit them. So that's about it for this video on GitHub. Thanks for watching this.